this is a crash course overview of what we have talked about this week with more domain and range, and then introducing transformations of graphs. So starting with the first thing we covered was if we want to create a graph given a certain domain and range. What we want to do to accomplish this is sketch on our graph with our solid and dashed lines, and then create a graph that meets those specifications. So there's many different correct ways to do this, but just a couple examples. On number 1, my domain is -3 to 5, and those are both brackets. So I'm going to indicate that with solid lines on my graph. Then my range is 1 to 4, both brackets. So that would be solid lines. And now this box in here is where my function needs to go. So I can just do 2 closed circles and connect them with a line. You could also have done it on the opposite 2 corners, but each of these x values and each of these y values need to be present on your graph. Then number 2, I have a domain of -2 to 3, and those are both parentheses, so I'm going to do dotted lines. And my range is -1 to +5, also parentheses. So what I can do for this is 2 open circles and a line to connect them. Okay. One more for good measure. Let's do number 3. My domain is from -3 off to infinity. And my range is from -4 parentheses to 2 bracket. So one way I could do this is to draw an open circle here, go up and off to infinity, and that's just one way that we could draw that graph. So when you are asked to draw a graph given your domain and range, you want to draw in your dashed and solid lines and then draw a graph that reflects that. Okay. Moving on to function transformations. So there is the parent function PowerPoint in Canvas for you to view, but there's different transformations that we can make to not just our parent functions, but other functions as well. That is shifts up and down or left and right. We can reflect over the x or y axis. We can stretch it and shrink it vertically, and we can stretch it and shrink it horizontally. So let's take a look at what each of those looks like. So I know this is not super great quality, so I'm going to draw this in. This is my quadratic parent function. It's a parabola. And so just a couple points that are on my parent function here. I'm going to make a t-chart of my x and y. I've got -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now a vertical shift up is indicated by adding a constant outside of the function, so outside of our parentheses at the back end. So when we shift up, we're changing our y values, and here we're told we want to shift up 2. So for my transformed function, I'm just changing my y values, so my x values will stay the same, and I'm going to add 2 to each of my y values. So this was my parent function points, this is my transformed function points, and I'm just going to plot them now on my graph. And draw in my transformed function. It's still a parabola, we just shifted it up 2 units. Okay. Same story for shifting down. This is my square root parent function. So some points on that one are 0, 0, 1, 1, and 4, 2. So here I'm shifting down 1, so I'm subtracting a number on the outside. My x values are going to stay the same, and I'm going to subtract 1 from each of my y values. And I'm just going to plot those points. And there is my transformed function. So vertical shift up or down, you're adding or subtracting a value on the outside. Okay. Next would be a horizontal shift, And that is indicated by adding or subtracting inside the function, inside our parentheses. So when we subtract a value, that's shifting to the right, and when we add a value, that's shifting to the left. So looking here, this is my absolute value parent function. So just a couple values that are on this parent function graph are -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Now, if I'm shifting to the right, that means I'm changing my x values, and my y values are going to stay the same. So I'm going to write in my same y values. And I'm shifting to the right, meaning I'm going in the positive direction. So my x values are going to be increasing by 2. Even though I'm subtracting inside my parentheses, it means I'm shifting to the right. So I'm going to add 2 to each of my x values. Okay. And I'm going to go ahead and plot them. And it's shifted 2 units to the right. So each of my x values increased by 2. Now again, over here I have my quadratic parent function. So I'm going to write some points on my graph. And I'm shifting now to the left. When I add a number inside my parentheses, I'm shifting to the left, which means my x values are changing. And they're going to be decreasing by 2. So I'm going to subtract 2 from each of my x values here. Okay. 3, 4. And here is my transformed function. We moved 2 units to the left. Each of my x values decreased by 2. So that takes care of our shifts. Next, we have reflection over the x and y axis. Oops, you can't see it. So when we have a minus sign in front of the function, on the very outside, that's a reflection on the x-axis. So remember, this is our square root parent function. So some of our values here. When I reflect over the x-axis, this right here is my x-axis. So it's going to flip from the top to the bottom, which means my y values are going to be changing, and they're going to be changing sign. So my x values stay the same. My y values are all positive here, so they're all going to become negative. Their value is going to stay the same, but they're going to be negative. And there is my transformed function. Minus sign on the very outside, we reflect across the x-axis, which means our y values change sign. Now, when we have a negative inside our parentheses in front of the x, that's a reflection on the y-axis. And again, we're looking at our square root function. So here is my y-axis. When I flip over the y-axis, my x values are changing. So my y values are going to stay the same. And I'm just going to change the sign of my x values. Okay, we reflected it across the y-axis. So those are our reflection transformations. Next, we have vertical stretch and shrink. So again, here's my absolute value. I'm going to make my table of points. A vertical stretch is when I'm multiplying in front of my function, in the very front, and when that number is greater than 1. So in this case, I'm having a vertical stretch by a factor of 2, and it's vertical, which means just my y values are going to change. So I'm going to leave my x values the same. And each of my y values is going to be stretching. That means increasing by a factor of 2. So I'm going to multiply each of my y values by 2. Okay. And now I can plot my new points. And here is my transformed function. It stretched. It got taller in the vertical direction. That's a stretch. Now, for a shrink, again, I'm multiplying in the very front, but that number is a fraction. So negative signs, remember the minus sign indicates a reflection on an axis. So we're just looking at the value itself. So here, if I have 1/4, now this is hard to see, but here's my cubic parent function. So some points on my cubic parent function. We've got -2, 8, -1, 1, 0, 0, 1, 2, 8. Okay. So now my vertical shrink, again, it's just going to be changing my y values. So my x values are going to stay the same. And I'm going to multiply each of my y values by this 1/4, which is equivalent to dividing by 4. So that 8 is going to become 2, 1/4, 0, 1/4. Oh, and those are negative, I apologize. Negative, negative, and these are positive. Should be -8, -1. So I now have -2, -2, -1, 1/4, 0, 0. And that is our vertical shrink. Our y values decreased. Okay? And last but not least, we have our horizontal stretch and shrink. This is when we are multiplying by something inside the parentheses. Oops, blurry. And then whether we're shrinking or stretching is the opposite from vertical. So for vertical, when the number was greater than 1, it was a stretch. For horizontal, when the number is less than 1, it's a stretch. So here is my quadratic parent function. So some of those points. Now I'm finding 1/2 of x. So it plugs in, because this is my quadratic, we have to square the 1/2 and the x. So this is going to be 1/4 x squared. Which means I have a horizontal stretch by a factor of 1/2, or by a factor of 2. That's not enough room. Let me write this over here. So my y values are going to stay the same, and my x values are going to be increasing by the denominator. So here my denominator is 2, so I'm going to multiply each of my x values by 2. And now I can plot my new function. So we stretched horizontally. We got fatter. Our parabola got fatter. And last but not least, horizontal shrink. And we have a shrink when the number being multiplied inside our parentheses is greater than 1. So again, this is our absolute value parent function. So when I'm shrinking, what's going to be happening to my x values is that they're going to be getting smaller. So I'm going to divide each of them by 4. And so I'm going to be shrinking in the negative direction, or sorry, in the horizontal direction. Okay? And this is all of our transformations. We have vertical shifts, horizontal shifts, reflection, vertical stretch, horizontal stretch.